Dear students, today I am going to tell you how to draw the structure of phosphorus oxides. First, we have to understand the structure of phosphorus. Phosphorus is tetraatomic, so it can be written as a P4. Tetraatomic, that means 4 phosphorus atoms, they always join together. That is why it is known as a tetraatomic in nature. Now let us see how to draw the structure of phosphorus oxide. Phosphorus. 4 phosphorus atoms are connected to each other, and each phosphorus atoms, they are also connected to each other. So now each phosphorus belongs to 15th group. When it belongs to the 15th group, it has got 5 valence electrons. Out of 5 valence electron, it uses 1 electron for this covalent bond formation, another electron for this covalent bond formation, third electron it uses for this covalent bond formation. So remaining 2 is lone pair that of phosphorus or each phosphorus atom. Similarly here, this phosphorus also, each electron it uses, out of 5 electron, 3 electron it uses for covalent bond formation. Remaining 2 electrons lone pair. Similarly, each phosphorus atom has got 1 lone pair. So total lone pair of electrons present on P4 is 4 lone pairs. And number of phosphorus bonds. So let us take one phosphorus atom and let us count here one bond, here one phosphorus bond, here one phosphorus bond. So each phosphorus connected to 3 other phosphorus atom. So pp bond for each phosphorus is 3. So each phosphorus is connected to 3 other phosphorus. So phosphorus connection is 3. These are the very important data for phosphorus P4. It is existing as a tetraatomic molecule. Now bond angle, that is the bond angle between the 2 phosphorus atoms. So this bond angle is 60 degree. That means bond strain is very high. Strain means the phosphorus atoms are not in a comfortable situation. So that means so the stress is more for phosphorus atom. So the phosphorus bond can break very easily. When this bond can very easily, we can say that the P4 is highly reactive, because bond can be broken easily because of strain. So P4 is reactive in nature. Reactive is meaning is what? It reacts with oxygen readily. When reacts with oxygen, what will happen? It forms phosphorus oxides. Actually, it forms 10 phosphorus oxides. We know only 2 phosphorus oxides, that is stable oxides, P2O3 and P2O5. These are the well-known phosphorus oxides. But actually, it forms 10 phosphorus oxides. For the sake of convenience, this can be written as a dimer. 2 P2O3 molecule, they join together and forms P4O6. Similarly, 2 P2O5, they exist as a dimer, that means they join together and forms P4O10. Now let us discuss how to draw the structure of phosphorus oxygen, that is phosphorus oxide. First let us draw the structure of P4O6. Very simple. You have phosphorus connection. 4 phosphorus atoms are present. See, instead of this phosphorus connection, you have to put 1 oxygen in the middle, that's all. For between each phosphorus and oxygen, between 1 oxygen must be present. Here also 1 oxygen must be present, that's all. Very simple. 4 oxygens over. 5th oxygen is between these 2 phosphorus, 1 oxygen. Then 6th phosphorus is between these 2 phosphorus, 1 oxygen, that's all. Lone pair of phosphorus is present as usual on the phosphorus atom. So now this is the structure of P4O6. Very simple. I'll repeat again. First draw 4 phosphorus atoms like this. So instead of phosphorus connection, you have phosphorus oxygen connection. Draw like this. Phosphorus oxygen like this. Then fourth oxygen will be between these two. Fifth oxygen will be 4, 5, sixth oxygen will be like this. And as usual, lone pair of electrons will be present on each phosphorus atom. Now count this phosphorus. How many phosphorus, oxygen and phosphorus POP bonds are present? This is a very important question. Neat question. How many POP bonds are present? So 1 POP, 2 POP, third POP, fourth POP, fifth POP, sixth POP. So total 6 phosphorus oxygen bonds are present. And lone pair of electrons on phosphorus. Lone pair of electrons on phosphorus is 1, 2, 3, 4. So lone pair on oxygen. So each oxygen has got 2 lone pairs. How 2 lone pairs? Oxygen belongs to 16th group. So it will have 6 electrons. Out of 6 electron, it will utilize 1 electron for this bond formation, another electron for this bond formation. So balance how much? 4 electrons are present. So each oxygen 4 electron means 2 lone pairs. 2 electron is equal to 1 pair. So 4 electrons are present on each oxygen. So 2 lone pairs are present on each oxygen. So how many oxygen we have total? 6 oxygen. So each oxygen you have 2 lone pairs. So 6 2s are 12 lone pairs. So 12 plus 4, altogether 16 lone pair of electrons are present in this molecule. If they ask number of lone pairs present in the molecule P4O6, you have to write 16 lone pairs. Particularly if they ask write the number of lone pairs or lone pairs of electrons on phosphorus atom means, then it is 4. For oxygen means it will be 12. So this question is very important. How many POP bonds, how many lone pairs, and what is the hybridization of phosphorus? This is another important question. What is the hybridization of phosphorus and oxygen? For hybridization, what we will see? Number of bonds that is connected. So let us see in the case of phosphorus, here 1 bond, here 1 bond, here 1 bond. So total 3 bonds plus 1 lone pair. So each phosphorus connected to 3 single bonds and 1 lone pair. Total is 4. When this steric factor is 4 means the hybridization is sp3. So each phosphorus shows sp3 hybridization. So this is the shortcut to find out the hybridization. So just count number of bonds plus lone pair. Add together 4 comes means s orbital and 3 p orbital. So total 4. So hybridization is sp3. And oxygen, let us take oxygen. Here take oxygen. Oxygen out of 6 electrons, 2 utilized for bonding, remaining 2 lone pairs. So how many bonds are there for oxygen? Oxygen 2 bonds are present plus 2 lone pairs. So 2 plus 2, 4. So again 4 is coming. Again the hybridization is sp3. So these are the details of P4O6 molecule. Next we are going to draw the structure of P4O10. Children, let us draw the structure of P2O5. That is, it can be written as a dimer P4O10. Very simple as usual. Take phosphorus atom, write 4 phosphorus atom. As usual, between 2 phosphorus atom, you have to write 1 oxygen atom. So 4 oxygen atom over. 5th oxygen will be between these 2 phosphorus. 6th will be as usual between these 2 phosphorus atom. Now 1 lone pair is present on each phosphorus atom. So that lone pair will be converted into double bond oxygen. Double bond O, double bond O, double bond O. 4 lone pairs. So lone pair will be removed. Instead of that, phosphorus oxygen double bond will come. Now tell me how many lone pairs are present in the entire molecule. So each oxygen you have 2 lone pairs. Here also double bond oxygen also you have 2 lone pairs. Total how many oxygen you have? 10 oxygen you have. So each oxygen 2 lone pairs you have in the structure. So 10 twos are, how many lone pairs are present? 20 lone pairs of electrons are present. Now let us calculate the hybridization of oxygen. So again let us take the structure oxygen. This oxygen, that is the oxygen which is present in between two phosphorus atoms. So that oxygen you have 2 lone pairs, 2 bonds. So 2 plus 2 4. So the hybridization is sp3 hybridization. Oxygen is sp3 hybridization. Phosphorus always will show sp3 only in this case. So here each phosphorus, how many connection? 1, 2, 3. Double bond O should be treated as a single bond. So around phosphorus you have 4 bonds. Again it is sp3 hybridization. But here we have 2 types of oxygen we have. One oxygen is present in between 2 phosphorus atoms. But another type is P double bond O. If it is P double bond O, what will be the hybridization? See, look at phosphorus. 1, 2, 3. Here P double bond O. This oxygen, when you calculate, start from oxygen. Oxygen. Here only one bond is present. That is double bond should be treated as a single bond for calculating hybridization. So here only one bond is present. But how many lone pairs? 2 lone pairs. So total what is the number? 2 plus 1 is equal to 3. So when the number is 3, it is sp2 hybridization. So phosphorus hybridization is sp3. Oxygen hybridization is sp3. P double bond O oxygen hybridization is sp2. How many P double bond O bonds are there? 4 bonds are there. So how many sp2 hybridizations are present? 4 sp2 hybridizations are present. How many POP, this oxygen is present? Remaining 6. So 6 oxygen atoms will show sp3 hybridization. 4 oxygen atoms will show sp2 hybridization. So the entire molecule data is lone pair when the molecule is 20 lone pair. sp2 oxygen is 4. sp3 oxygen is 6. This is the entire molecular data. So listen, I think that hybridization calculation, I'll repeat again. Just take the atom. Around that atom you check the number of bonds plus lone pair. Together you have to add. If the number is 4, then sp3 hybridization. If the total is 3, then it is sp2 hybridization. If the number total is 2, then it is sp hybridization. That's all. Very simple. So this video we have discussed the structure of P4 and the structure of phosphorus oxide P2O3 and P2O5. Hope you have enjoyed this video.